Hello, my name is Jonathan Rodriguez, and we are Team 798. We were sponsored by TI to upgrade their wafer handlers, and we did this by implementing 3 systems. The first of which Christian Atchie and myself worked on, and this was to automate the clean dry air system, also known as CDA.
I'm Tyler Watton. This is John Oliver. We implemented a system that monitors the profiling process and displays errors if one occurs.
Hi, my name is Shannon Lowe. This is Chris Hampton, and we designed System 3, which is to create an optical solution to determine media wear and media type and media wear.
So what is media? The burnishing media is a paper that's installed onto the burnishing block to clean the probe needles. So we used a Raspberry Pi with a custom camera and lighting system to detect the media wear and usage. We took advantage of the fact that there are 3 different media papers that are each different colors for the type detection, and then we use contours for calculating the usage. The profiler system is used to measure the thickness of the wafer, and over time there can be deviations in this process which cause deviations in the measurements. So we installed a sensor that will continuously measure the PSI throughout the profiling process and will log any errors that a technician can later reference to. CDA is important for high voltage testing. During high voltage testing, arcing can occur between the probe needles. So CDA contains nitrogen, which deionizes the air and prevents this arcing. TI currently has a manually activated and monitored system. So we designed an automated CDA system that's triggered by a GUI and it displays real-time flow measurements as well as error detection. So this project, we also implemented an audible alarm that will trigger anytime an error is detected. This project will improve profitability by preventing damage and optimizing usage, as well as increase safety and awareness with real-time error detection and an alarm system. Any questions?
I'm still a little unclear about what this machine, can you tell me about what this machine does and what the media does?
Yes, sir. So that's a wafer handler. So that's an EG type. They have many different types. So that was another challenge. We had to integrate all these systems on not only on this machine but other one. But this is a wafer handler. So it actually there's a test cell that docks to this handler. So the primary function of this machine is just to load the wafers out of the cassette before testing.
Okay, so then what does the burnishing media do?
So if you can see right here, if I come over here, there's a wafer chuck. So the wafer sits on this chuck, and there's a burnishing block right here. So the different types of media that are installed on this block. So in this cell right here is what's called a probe card. So it's probe needles that actually touch each individual die on the wafer. So as you're testing, the probe needles can become contaminated, which affects contact resistance and affects your test integrity. So each probe needle is made out of different material as well, so it requires different burnished media. And currently, their current system, the technician will change the media as required and hang a sign on it. So our GUI offers, real-time image of what's on there, and it optimizes the actual usage. So they change the paper based on a time frequency currently.
Okay.
So did you retrofit this into a real machine and see any results?
Yes.
So what was the result?
So we have a machine downstairs, and it will do all of this and then some. It's quite effective.
So what are the performance or capacity or other parameters that you used as reference, and you meet them or exceed them?
So actually, TI challenged us with this project to actually, so we're going to install it on the first real machine next month, right? And then we plan to fan this out across the world. So raw calculations based on my manager works at TI, so is $500 per machine, and there's 3,000 of these machines across the world. So it's about $500 per year of real-time savings.
What was the
Or Yeah.
The main problem you had to realize this now, what was the main different problem?
The main problem
Yeah.
is a totally, so this is a complex project. It's like 3 projects in one, right? So there's many problems here. So the burnishing paper is not being fully utilized and wasted. And so say the technician works 12-hour shifts and he's in the process of changing it, and perhaps many times the wrong media is on the wrong device type, so that can damage probe cards.
What was the difficult part for your project?
What was the biggest challenge?
Oh, the biggest challenge was because this is 3 simultaneous projects in one, but I would say like the most difficult
Well,
is
part of it also is that we didn't have some of the metrics we couldn't get. Were not given to us because some of the, like for example, the CDA is still in process of research. So we had to make that CDA system robust to where if someone's going to do some testing, they can change the metrics to where it's going to pass, fail, show some errors. So that was one thing. Another thing is that there's 4 different types of settings, configurations, and allowing the user to select what configuration they want per machine was another challenge for us, right? And also for example, for the burnishing paper, if you can see that there's white and gray, when we're trying to detect the wear and also trying to detect what type it was difficult to differentiate sometimes the different colors. So we had to adjust our process of how to detect wear detection, and even color detection.
All right, let's thank the team.